Welcome to another Chapter 6 video. This one is dealing with the sampling distribution, and we're just going to look at some basic concepts to get a general understanding of what it means. This first video is not an actual problem. It's just to help you understand so that when they're asking questions, you get a better understanding of what it is they're looking at. So first of all, we're going to look at what a sampling distribution is. It is a collection of averages from samples, from all possible samples. The data points here, X bar is a data point. In just a normal distribution, it's an X data point. So we're going to be looking at what's called the X bar distribution. The X bar distribution. We're typically going to be looking at it using the normal distribution. But first, let's look at an example of what it actually is. So if we have a population data where the numbers are 68, 69, 70, 71, and 72. So 5 data points. Easy to deal with all your calculations there. It has a mean of 70. Easy to calculate. You have all the data points. When we're looking at the sampling distribution, and we're going to look at for samples of size 2. N equals 2. That's our sample size that we're going to be dealing with. In creating this, we need to look at the sample and the corresponding average, X bar. That's the data point. So one possible sample would be 68 and 69. That gives us an average of a 68.5. That would be one data point. We could sample 68 and 70. Gives us an average of a 69. A 68 with the 71. An average of a 69.5. And we could do the 68 with the 72, an average of 70. That's all the possible samples of size 2 where 68 is part of it. If we look at starting with a 69, it could be sampled with a 70, an average of a 69.5. So you see a value that's been repeated. You could sample a 69 and the 71. Gives us an average of a 70. Again, a repeated value. We could sample the 69 with the 72. That would give us an average X bar of 70.5. That's a new value. That's all of them that can have 69 but not 68. So jumping to the 70s, we could do 70 and 71. Average is also 70.5. Another repeat. We could do 70 with the 72. Average 71. Then we could do the 71 with the 72, average of a 71.5. So those would be the collection of all possible samples of size 2. You'll notice there are 10 of those. That's larger than your actual population. Calculating and actually using this is not feasible if you have the actual population. The sampling distribution is used for approximations, and we'll look at those as we go through other practice problems. Things that I want you to note. The mean of this sampling distribution, if you pause this and calculate it, you will find that it is 70. In fact, the mean of your sampling distribution is equal to the mean of x, and that's always, regardless of what your distribution is. Your standard deviation of x bar is equal to the standard deviation of x over the square root of n under certain circumstances. So if you meet certain priorities, conditions, then that will also be the value of the sampling distribution's standard deviation.